Okay, we have a series n³ over n⁴ plus 4. With this one, we do the integral test because it's monotonic decreasing. That means all the terms in the sequence of the series are decreasing. So the series is going to be increasing because you're adding positive terms, but your sequence is going to be decreasing with each successive term because we have a power of 4, which grows faster than the cube power. So every time we add a number here, the denominator is going to get larger and larger with each successive term in that sequence, which means that the term as a whole becomes smaller. And that's what we want for the integral test. We also want all the terms to be not negative, and they're never going to be negative because we're plugging in positive numbers from 1 to infinity. And this is, obviously we don't have any negative multiples in there. So we're going to do the integral test. How do we do the integral test? We integrate what we have in there. So we could change these to x's, or leave them as n's, whatever, dx. And with this one, if you remember, it's been a long time, but we have x³, and here we have x to the 4th. So naturally, we let this be u, because that's going to give us a derivative with a cubed. So this is how our steps look. We take the derivative of this. This becomes 4x cubed. That goes away. Dx. Now we can make our substitution back by solving for dx, which is a term we have in our integral. So we are left with x³ over u, and then du over 4x³. The x³ are going to cancel out. So we have 1 over u, and we have 1/4. The 1/4 comes out because it's a constant, 1/4. And so that's our situation. This is natural log. Natural log, once we evaluate, this is what we have. Let's remember what our bounds were. They were from 1 to infinity, 1 to infinity. We can't work with infinity directly with these integrals, so we replace that with a t. And we take the limit as t approaches infinity, the limit as t approaches infinity, and the limit as t approaches infinity. With this one, we can make our substitution back because we didn't change the bounds. So we have to make our substitution back. We let u be x to the 4 plus 4. And now we have an upper bound and a lower bound. Our upper bound is t, which is going to go to infinity, and our lower bound is 1. We get our 1 from here. So now we have two things, and we subtract the lower from the upper. In the upper, we have 1/4 natural log of the absolute value of t to the 4th plus 4, like this. On this side, we plug in 1 in there, and 1 to the 4th is just 1. But actually, whatever that was doesn't really matter because we're taking the limit as t approaches infinity. And what happens when we plug infinity into the natural log? We're going to go to infinity because remember, the graph of natural log goes like this, but it keeps growing and growing and growing. So it does grow upwards forever. There is no horizontal asymptote for the natural log, so this is natural log of infinity, which is infinity, which means that this diverges.